Have you ever wanted to study the ocean and work on a scientific research ship at sea? Today, I'm going to take you into the life of being an oceanographer and teach you about all that we do. Hi everyone, my name's Leah and I'm an oceanographer. I've had the dream of being an oceanographer since I was a little girl, and I'm so happy that I get to study what I love every single day. Oceanography is the study of the ocean in simplest terms, and it can typically be divided into three categories. Biological oceanography, studying the plankton, fish, and marine species within the ocean. Chemical oceanography, studying the water chemistry that aids this biology, like looking at dissolved oxygen, nutrients, carbon, or chlorophyll in the ocean. And physical oceanography, studying how the ocean moves, mixes, and circulates, which is what I do. Let's talk physical oceanography. Did you know that the ocean is like a giant conveyor belt that moves water from one end to the other? This conveyor belt-like circulation is what scientists call thermohaline circulation. And this plays a huge role in the transport of heat, salt, and nutrients around the globe. Just as regions of the globe differ in their temperatures, regions of the global ocean vary too. The poles are full of cold water, with temperatures about 0 to 4 degrees Celsius. Brr! Water near the tropics and the equator, on the other hand, are very warm, ranging up to 30 degrees Celsius. Thermohaline circulation, in addition to oceanic gyres and currents, move hot water from the tropics to the poles and cold water from the poles to the tropics. This keeps Earth at a comfortable temperature for all. If it weren't for this distribution of heat in the ocean, the poles would be extremely cold and the tropics would be too hot to handle. Physical oceanographers study ocean circulation to observe this transport of heat, as well as the transport of water in general. Let's focus on the Gulf Stream here off the east coast of the U.S. Can you guess how much water is transported by the Gulf Stream? The answer is about 30 sphere drips, which is a unit of measurement oceanographers use to describe water transport. One sphere drip is equal to 260 million gallons of water per second. So let's calculate this out. Grab your calculators. 260 million times 30 equals... Whoa, that's a lot of zeros. Now, an Olympic pool is about 660,430 gallons. This means, divide these two... The Gulf Stream moves about 12,000 Olympic-sized swimming pools worth of water each second. That's a lot of water. Still, even with this large volume of transport, it takes around 1,000 years for water to travel all the way around the globe. Water starts its transport journey in deep water formation zones, where salty, warm water that came from the tropics cools significantly from being in a polar region. This mass of water then becomes extremely cold and dense and sinks from the surface to the ocean floor, driving this overturning circulation. As oceanographers, it's our duty to collect the data needed to observe ocean circulation, as well as to see how it's changed over time. To understand the ocean surface, scientists use satellites in space and ocean buoys to understand the sea surface temperature, as well as surface drifters, enabled with GPS signals that allow us to track and trace ocean currents with their velocity and their direction. To collect data of the ocean interior and the deep ocean, we head out to sea. Depending on where you're headed, a typical research cruise can be a few days or it could be a few months. Scientists eat, sleep, exercise, and conduct all research while at sea. Scientific research vessels are equipped with many different types of instrumentation to collect ocean data. A CTD package is used to observe the ocean and collect data from surface to seafloor. The CTD package contains a variety of sensors and bottles that collect many different types of data: oxygen, salinity, temperature, and pressure, for example. ADCPs are also on the package. These instruments measure velocity through the water column above and below the CTD and show interior and deep ocean currents with their direction and speed. The CTD is lowered from the ship at the sea surface to the ocean floor using a cable, and Niskin bottles are closed at certain depths to collect water samples. Once back on board, scientists use these water samples to measure seawater chemistry such as pH, carbon, oxygen, nitrates, phosphates, and other nutrients. One cool thing about Niskin bottles is that it allows us to sample water all the way from the deep ocean. Do you know how deep the ocean actually is? On average, the ocean's around 3,600 meters, which is 12,000 feet deep. That's about 300 school buses stacked on top of each other. The deep ocean is cold, dark, and dense, and it's really difficult to measure things all the way at the bottom of the ocean due to the enormous amount of pressure that's exerted on objects at these depths. Have you ever dove in a swimming pool and felt your ears pop when you hit the bottom? This is just like the ocean, and pressure increases as you decrease in depth. Pressure at the bottom of the ocean is immense, and scientific equipment must be tough enough to survive and collect data at these depths. Did you know that at 2,000 meters, so about halfway through the water column, there is roughly 2,800 pounds per square inch of force exerted on you? That's like having a hippopotamus standing on every inch of your body. One fun activity that oceanographers do at sea is shrinking cups. If you attach a styrofoam cup to the CTD and send it all the way down to the bottom of the ocean, when it comes back up, it's super tiny because all of the air was squeezed out of it due to the compression at the bottom of the ocean. I hope you learned a thing or two today about oceanography and ocean circulation and the importance of why we collect this data. Ocean data is very important, and it's used in weather forecasting, climate modeling, and many, many other forms of research. I hope one day you too will get the opportunity to conduct some oceanographic research. Everyone can be a scientist. Thanks for tuning in, guys, and I hope to see you at sea.